Hi everyone, I'm Devin Boker, and this is The Wildlife. Today we travel to Tanzania to answer a question that has plagued scientists at least since the days of Alfred Russel Wallace and Charles Darwin, and you probably haven't thought of since you were a kid. It involves stripes, a change of perspective, flies, and one very determined man. The mystery of zebra stripes has been the subject of debate for a pretty long time. It's one of those questions that children have, kind of like, why is the sky blue? Sometimes parents know what to say, sometimes they don't. Most commonly, parents will say something like, oh, it's for camouflage. But thanks to Dr. Caro, we finally have our answer. And the story of how he got it is pretty interesting.
Hi, my name's Tim Caro. I'm a professor of wildlife biology at the University of California at Davis.
That's him. The first question I had for him was, why study zebras?
Well, I've been interested in the functions of animal coloration, specifically in mammals.
Which sounds a bit odd because normally when you think of mammals, you don't really think of exotic colors like lizards and birds. You think of boring colors.
Drab, grays, and browns, not very interesting.
Not the most exciting colors.
And there are a few notable exceptions like the giant panda or the giraffe.
Or in this case, the zebra. Now when you think of zebras, you think of bold, contrasting stripes, the black and white, the black and white. And humans have obviously taken an interest in them. You see them everywhere from awful-looking carpets, clothes, furniture, pretty much everywhere.
So that's how I got interested in looking at zebras in particular.
People have been hypothesizing about what purpose zebra stripes served for a pretty long time. Charles Darwin and Alfred Russel Wallace argued about it, and I asked him about how many ideas are there about what they're for.
Well, it depends how you categorize them.
What does that mean?
But there are about 8 or 9 major hypotheses.
Those are the ones like confusion of predators.
That sort of answer to confuse predators comes in many different forms. And so you can break these hypotheses down into almost 20 subheadings. And the purpose of the research that I've carried out over the last decade has been to systematically try and chip away at each of these hypotheses.
Yes, you heard that right. The scientific method at its best, trial and error, over and over, trial and error, trial and error. Over the last decade, every summer he has spent in Tanzania studying each of these different ideas.
To see whether they stand up to scrutiny.
You see, oftentimes in science, it starts with an observation or an idea that you want to prove either right or wrong. In this case, that wasn't good enough for him. What he wanted to do was to systematically go through each and knock out every single thing that was wrong to narrow it down to what would be correct.
So what I've done in this book that came out last month.
That's right, I should mention, he does have a new book out, came out last month, fittingly called Zebra Stripes.
Was to try and investigate systematically each of these ideas.
Each of these ideas. So some are about individual recognition.
Some are about camouflage.
Confusing predators and
trying to avoid biting flies.
So we did this every single summer for 10 years in western Tanzania. That's research, nothing. Research, nothing. Research, nothing. Research, nothing. Research, nothing. Research, nothing. Until finally an answer, but we're not there yet. You know, I had to wonder, and I had to ask. Did it ever feel like you just wouldn't ever find the answer after so long?
Yeah, and it's actually an interesting period of self-discovery, really, because each summer I would collect together some new equipment to test a new idea.
Tools in hand and optimism on mind.
And I would go out to western Tanzania full of hope and then return to teaching in October rather depressed, having failed to make any headway. So when that happens again and again and again, you begin to wonder whether you're ever going to get it.
So, first up?
But camouflage is the oldest hypothesis.
And so they wanted to test it out. So the way they did it is they made plywood horses, some of which were painted gray or brown, some of which were painted striped, like a zebra. And then they set them out at night or early in the morning and watched.
Would watch these models disappear at night or reappear in the morning, and with the idea of seeing whether the zebras are less or more easy to see than the other uniformly colored models.
Now, anyone who's ever had to look around in the dark can probably assume the result right away.
The results from that were loud and clear.
Come on, the zebras. But here's what's really interesting. And this is actually one of the reasons that I contacted Caro in the first place. See, the researchers, when they were making these observations in the evening and in the morning, were looking from a human eye.
And humans can see in three colors, whereas most carnivores like lions and hyenas can only see in two colors.
And after all, isn't the whole point of camouflage hiding from your predator? So to see if it was really camouflage that was the purpose of the zebra stripes, they had to look through the eye of a lion.
So we then embarked on a modeling exercise with some colleagues from Canada, Amanda Meehlin at the University of Calgary leading this.
Knowing what they knew about the size of the eye and the numbers of rods and cones,
we could try to work out whether these large carnivores could see stripes and at what distance they can see stripes.
and what did they find?
These carnivores can only see stripes at very close distances.
Which means that by the time they're even close enough to see the zebra in the first place, they're already way within range to be able to smell it or hear it.
And so the idea that these stripes could act as camouflage against lions and spotted hyenas at a distance is really inconceivable.
So at this point, you can consider the idea of camouflage as a function of stripes
stone dead.
So, another summer, another hypothesis debunked, but still a mystery. Which brings us into part 2. As we begin part 2, we're going to start by talking about a completely different organism than zebras: flies. We know from experiments about 35 years ago which tested what kind of surfaces that biting flies would land on or avoid, that for some reason they don't like striped surfaces. This is biting flies. So horse flies, tsetse flies, which tsetse flies are the ones most commonly known for being a carrier of sleeping sickness.
And we don't know the reason that they don't like landing on these surfaces, but we know that they either avoid them or can't see them.
So at this point, it was a matter of confirming this in the field.
So we set up deer and horsefly traps.
We're talking about the kind that are sort of like an inverted tent, which were then set up about a meter off the ground.
And then hanging from that middle of that tent is a kind of beach ball.
And that beach ball was painted black and it would lightly wave in the wind. So it would really, really work well to attract those flies.
And so we were able to wrap these balls either in a wildebeest skin,
which again look kind of dark gray or brown,
or in a zebra skin, and then look at the numbers of horseflies that we caught in these tabanid traps.
But before we get to those results, I want to talk about a couple of the other ways that he tried to figure this out. This one is pretty interesting. You see, the tsetse flies that were in that particular area,
Glossina morsitans,
were realized to only like to land on moving targets. Caro decided what better moving target than himself. So he went to the Tanzanian capital,
Dar es Salaam,
where he had a series of suits made, some brown and gray, some striped either horizontally or vertically,
and then recorded the number of flies that were on me when I got back to the car.
And you have to imagine that that whole experience must have been a little tense, and if it wasn't, I don't know what to say, because he's walking through an area known to have lions essentially dressed as a zebra. As it turned out,
we didn't get many results there, and I think that the reason is that perhaps the stripes were too wide, or else the reflection of cloth is not quite the same as the reflection of fur.
So not exactly any answers there. So let's go ahead and rewind back to the beach ball experiment. So just to recap, we had the beach ball hanging either covered in a wildebeest skin or a zebra skin with a fly trap attached to the top, and then measuring how many flies were actually stuck to that trap. And as the previous research would have suggested, the number of flies were
really significantly reduced if the attractant is a zebra skin that's slowly blowing in the wind.
And while that is certainly some great evidence, it's not enough to prove the idea. So back in America, California, about 100 yards away from his office, he went to the library.
Well, what we did is we capitalized on the fact that there's variation in striping between different subspecies of zebras.
All right, here he gets a bit technical, so I'm going to go ahead and skim past that. In summary, the different subspecies have different thickness or numbers of stripes. So what they did...
So we laid out geographic maps of where these subspecies lived.
And then they overlaid those maps with things such as known lion distributions.
Where there's a lot of woodlands, which would test the camouflage hypothesis.
Where there were lots of tsetse flies.
And we knew about group sizes, so we could test some ideas about communication between conspecifics, between members of the same species.
So all of these maps were overlaid in different combinations to see if there could be any visual relation between the stripe thickness or coloration or contrast and any of these other factors.
Mm-hmm. But then you can ask, in a sort of multifactorial statistical analysis, you can say, which of these ideas best explains variation in striping across the equid family?
And lo and behold?
And none of them are any good at explaining that variation except the abundance of biting flies.
So basically, wherever the flies were most abundant and wherever they preferred to breed, that's also where the zebras were that had specifically dense patterns of stripes.
This is the one that we're certain is the function of zebra stripes.
So, there you have it. After a decade of summers and countless hours of research, the answer ended up being confirmed just 100 yards away from his office. But of course, that's not the only reason I wanted to share this story. The thing that drew me to this was his perspective. Now, we are going to dive a lot deeper into that in the upcoming episode Spectrum. But something to think about now, at least while you're waiting, is we look at everything through human eyes. And often we don't take the time or take the effort to try and see things from a different perspective. Now, obviously, we have human eyes, so that's how we see things. Everything we have is designed for human eyes. As Caro said, humans see in 3 colors. That's why our TVs have the RGB. You know, and that's one of the reasons that I find Caro's research so interesting. Humans often see themselves as the center of the planet, center of the universe. We know that. Now, what he did was he looked at things not just through the eyes of a human, but the eyes of a lion, the eyes of a fly. He actually put himself in the position of a zebra, all for the sake of truth. Multiple times in our interview, he referenced the ideas that parents will explain to their children as sort of the fairy tale reasons as to why zebras have stripes. Now, we have the real reason.
Yeah, I think that the importance of this sort of work is twofold. One is that it's important to try and carry out basic research to understand the natural world. But in addition, it's important to try and encourage young people to ask finer questions about nature and to get more involved with nature. Right now, I've written a second book with my son, who's an artist.
It's a children's book, and they're not yet complete on it. Hopefully they'll have it wrapped up by the end of the year. And he's especially excited to share with people that
science is as important, if not more fascinating, than the fairy stories they're told by their parents when they're young.
And there you have it. That wrapped up our interview. And as I said, we will dive deeper into the topic of perspective in the upcoming episode Spectrum. I don't want to give too much away just yet. I cannot wait to share with you what we have in store. Special thanks to Dr. Tim Caro. Thank you for listening. This is The Wildife with Devin Boker.